Hello, hi everyone. This is Hitesh here. So today's topic will be your databases. Okay. Now, before going for the databases, let me ask you one question. What is meant by data? Okay. What is meant by data in your terms? You can say that it is a collection of a distinct or small unit of any information, right? And it can be used in various a variety of forms like text, numbers, media, bytes, etc. Right? And it can also be in short in many pieces of paper or electronic memory, etc. Right? So, word actually data is basically originated from the word datum. It means that single piece of any information, and it's a plural form of the word datum. In computing environment, what happens? Data is an information that can be translated into a form for efficient movement and processing. Right. So data is a interchangeable. We can predict this one, these things. The next important part is what is meant by database. Definitely, if we have a data, in order to organize that particular data, in order to access that data and manage the data efficiently, okay, we have a one type of a organization mechanism which is called as a database. Okay, we can organize the data into the table, rows, columns, indexes to make it easier to find the relevant information. And database handlers create a database in such a way that only a set of software program provides the accessing of the data to all the users. If you see, there are many dynamic websites has been available on the World Wide Web. Now all that particular websites is being handled by the through the databases only, because the whatever the data will going to come into that particular website, that is going to store in a, some kind of a databases. And there are many example of a databases like MySQL. We have Sybase, we have Oracle, we have MongoDB, we have Informix, then PostgreSQL, SQL Server, etc., etc., etc. Right. Now, next, evolution of databases. How the particular database has been evolved. Okay, what is the journey of a particular database? What are the different types of network models or different types of data models we have? Okay, what is meant by a relational databases or cloud databases? So these all the things we're going to see. Now, more than actually 50 years of journey has been there for this particular for databases. Starting from the flat file to the object relational databases. Okay, it has gone through several different types of generations. Okay, we'll start with a file base which is given, which is the first in 1968. Is a kind of a database which was introduced, and in this particular databases in file based mostly we maintain the data in the form of flat file. Okay, although means many advantages has been available to this particular file based database, but there are several limitations also. And one of the major advantage, if I talk about the file database, okay, it's a sequential and index and random kind of an access method it has. Okay, and it uses and it requires the extensive programming, that is our one programming languages like a COBOL and the basic, in order to accessing all the data in the file based system. Next, we have a hierarchical data model. As we know, this hierarchical is actually a kind of a tree like structure, right, having the parent child relationship, which having, you can say, the prominent hierarchical databases model was the IBM's first DBMS, which is also called as Information Management System IMS, right? Where there is a kind of a root node, and inside the root node, inside the parent, there is a several parent and the subchild has been given, right? And the model is also having some kind of a limitation because just the complex implementation and lack of the structural independence and having the many to many relationship, it is little bit difficult to handle the hierarchical model. Then in order to sort that, we have a one particular model we got, that is called as a network data model, which is developed by the Charles Bachman only, okay, at Honeywell, which is called as the integrated data store, okay, IDS. It is developed around in 1960, but it got standardized by the this Coachx group in 1971 only, where mostly it can be identified into several components. This particular network data model, like network schema, sub schema, we have data management language, we have, but it having some kind of a limitations also due to the system complexity, or maybe due to the difficult designing of this particular databases or this network model and the maintaining of the network model. So with respect to that particular disadvantage, one next particular and important and famous database came into existence, that is called as relational databases, that is called as RDB. Now, which is the present also and present era of the relational databases management system, which uses the kind of a relational model and entity relationship coded form, which having the many mostly two main terminologies. One is called as an instance, and second one is called as a schema. Okay, instance is nothing, it's a basically a table with a rows and a columns, and schema is nothing, just like the structure of your particular relation or particular instance, each type of a column name and the roll number which is given. So this model uses the some kind of a mathematical concept also, like a set theory and the predicate kind of a knowledge. Okay, and due to the era of this RDB, many more models has been introduced, like the cloud databases, NoSQL databases, like this. Or the cloud databases is nothing but is facilitate you to, you can say, store the and manage and retrieve the structured and unstructured data to the cloud platform. And NoSQL databases, where it is a kind of an say a method to design that type of databases which can adjust and accommodate a wide variety of our data models. Okay, NoSQL stands for means not only SQL, so it's an alternative to the traditional relational databases. And some examples I can give of the NoSQL databases like MongoDB, CouchDB, then we have a CloudGent, and then HBase, Bigtable, Akimbo, Coherence, Redis. These are some examples of the NoSQL databases. Okay. Now coming to the next particular topic, which is called as a DBMS. What is meant by DBMS? Okay, that is database management system. Right. Now we know that in order to manage this particular data in an effective way, okay, we require one kind of a management system, or require that one mechanism which manages this data perfectly and efficiently, without any kind of getting any kind of error, programming logic and all other structure and schema types. Right. So in order to manage that all the data efficiently, we have one system which is called as a database management system. Okay. This database management system is actually kind of a software which uses the, you can say, particular system mechanism in order to handle the data and maintain the data. Next, we have a types of the databases, like centralized databases. We have a distributed database, relational database management system, then NoSQL database management system. Then we have a cloud database, an object-oriented database, hierarchical database, and the network databases. So these are the types of the databases we have. And coming from the starting from the centralized database, okay, it acts as a, you can say, it confers the users to access the stored data from the different location to the several applications. So where the many particular different types of an applications is connected to the central server or central databases, where every applications can able to access that informations from the one specific location, so without having the any kind of an data distributed property, right, which reduces the little bit of task of the network data model, and which the application can contain the authentication process to let the user access the data securely and very efficiently. Okay. Next, we have that is distributed database. Distributed databases, you can thought like you can say different means different organization, like a communication link, the links which helps the end users to access the data very easily. Okay, and some of the examples of distributed database, we can talk about the Cassandra and the HBase, which is one of the famous particular databases. We have distributed database, right, which divides the particular database into the homogeneous databases and heterogeneous database, and those database systems execute on the same operating system which uses the same application process, and heterogeneous will execute on the different operating system which include the under different application procedures. Okay, their modular development and system expansion can be the biggest advantage of the distributed databases. Next, we have a relational databases, which is used on the relational data model. Just I have told you, we store the data in the form of table, rows, which is also called as tuple, in the column, which is also called as an attributes in the form of table. Together of tuples and attributes make a table, which is also called as a relational. Right. So relational uses the SQL for storing and manipulating as well as maintaining the data. Right, and there are many means commonly four commonly properties which is associated with the relational databases. We have called as an ACID properties. ACID is regarded as the, you can say, atomicity, consistency, isolations, and durability. Atomicity, you can talk about like which ensure the data operation will complete either with a success or either with a failure. Consistency, we can that if any kind of an operations is performing over the data, okay, or any performing on the particular applications or any kind of an activity on the data, is value before and after the operation should be preserved. Okay, for example, if you're taking the account balance example, before and after the transition it should be correct, so it should remain the conserved. Next, isolation, it means that concurrently users should access the data at the same time from the same databases we have, so the data should remain isolated here. For example, when the multiple transactions occur at the same time, one transaction effect should not be visible to the other transaction in the databases. And durability, of course, which ensure that it completes the operation, commits the data changes, and should remain the permanent. That's called as a durability. NoSQL databases, you can say not only SQL, is a type of database which is used to storing the wide range of data sets, and which is used to store the that data sets which is not in the form of a rows and tables. Okay, it is mostly stored in the form of documents and fields. Okay, and presented a wide variety of databases technologies in response to the demand. And basically we can divide this NoSQL database into different four types, like key value storage, then graphical database, then wide column stores, then document oriented databases, like this all things. Next, we have a cloud database, which, as we have discussed, is a kind of a database which is stored in a virtual environment and execute over the cloud computing platform, and provides the user with a various cloud computing services like SaaS, PaaS, IaaS. Okay, this type of cloud servicing computing services has been provided for accessing the databases. And the numerous cloud platforms also available which provide the cloud databases as well as Amazon Web Service, Microsoft Azure, then Kamatera, then Phoenix Snap, and the Google Cloud SQL, like all those things. Next, we have an object-oriented databases, which is a kind of an which uses the object model approaching for storing the data in the database system and represents the data and store the data as an object. Okay, and similar to that object we use in the, actually you can say how we create an object in the object-oriented programming language. Similar to that, we just store the data in our databases. Next, we have a hierarchical, which we have taught about, like it's kind of an parent-children relationship nodes, which organizes the data in a very tree-like structure and store the data in the form of records the data and connected the data in the form of links. Next, we have a network databases, which typically follows a network data model only. So the representation of data in the form of nodes connected via between them. And unlike the hierarchical database only, it allows the each record to have some kind of a multiple children and parents to form the generalize the graphical structure. Right, now we'll see what is meant by RDBMS, which is the current database management system. RDBMS, which is the SQL form of the database management system, also called as relational database management system. So this RDBMS is basically a concept where we use the specific concept called as a relation, and relation is termed as a table. Right, this particular relation uses the attribute and a tuple. The combination of attribute and a tuple is said to be in relation. Right, so which uses the stored data in the form of a table format. All the modern database management systems uses the RDBMS mechanisms only. Like SQL, we have, then we have Microsoft SQL Server, then we have IBM DB2, then we have Oracle, we have MySQL. Okay, so this type of modern database management system uses the RDBMS. Okay, and this is most commonly used databases nowadays, because here it contains the several table, and each table has its own primary key, okay, and unique key in order to identify the different things, right? Now coming to our end of this session, this is all about the database. Now if you wanted to learn in deep how does all the databases work and what are the different databases we can work upon, okay, so you can connect to the Coachx.Live. Definitely they're going to guide you at the best level. So for now, today I'm just stopping here. So tomorrow I'll come again with a new topic. So bye bye everyone, take care.